So let me thank the organizers for inviting me here. And the title concerns Seminar on Science and Freethought. I would make two assertions here. That free thought is essential for the progresses in science. But science puts a limitation to our free thoughts. It is the pieces of evidence that science marshals before us puts limitations to the free thought. For example, the pieces of evidence that we have here would not allow us to say that the sun goes round the earth. The freedom of thought may allow that to assert. You may even see the evidence, but that is not what can be attributed to what happens in reality. And therefore, science is a process which does not depend on thought alone. It depends on experiment. If we go to our school textbooks, in chemistry laboratories, you will be taught to divide your notebook into three parts. It is experiment, observation, and inference. These are the pillars of science. In every part of it, thought comes in. You do not make thoughtless experiments. But once you have arrived at an inference, that immediately leads you to a limitation. That you have reached a step. If you have to go further, you cannot keep debating the same question, no matter how much freedom you may be allowed. And this is one of the things that we follow in science. Sometimes it is not possible to do experiments. For example, in astrophysics, the discipline that I'm in, you may study the interaction between galaxies, but you cannot say, give me two galaxies. So your observation and experiment then get linked together. And sometimes these are the kinds of observations you cannot make at your will, because nature does not allow that freedom. You cannot say that, let me bring Mars in between us and some other planet so that I will measure the diameter of Mars. It was referred just now. It is not possible. And there you have to make certain connections of several pieces of observations. And what is your experiment? Your experiment is your thought process in determining what observations are to be done. So it is the laboratory in which nature is carrying on its, if you can say, the steps in experiments. And we must understand what experiments nature is doing. This is one of the essential issues that is there in science. That is experiment, observation, and inference. And sometimes to arrive at an inference, it takes centuries. For example, now today we are agog with issues related to things like the gravitational waves. Now, gravitational waves were predicted by Einstein over 100 years ago. Now, question is, are they there or are they not there? This question could be definitely answered once the gravitational waves were detected. But we still believed in gravitational waves because of few factors. And what were the factors? That Einstein based his entire theory on the question of bending of space-time because of presence of mass or because of acceleration. and predicted a few things. And what were those predictions? One of the predictions was about the approach of the perihelion of Mercury. So here is our sun, and Kepler had shown they all go in elliptic orbits, unlike what Copernicus or Galileo believed. Galileo believed in circular orbits. Though he had said many things correct, this is where he was incorrect. And that is where it doesn't depend on reputation. Okay? It does not depend on reputation. Same Galileo, who is known for many of his laws, was incorrect and obstinately incorrect. Okay? Now this is called an elliptic orbit, but this elliptic orbit does not retrace itself over and over again. Today it may be here, tomorrow another elliptic orbit, but here. Next one may be here, next one may be here, next one may be here. All elliptic, but the axis of the ellipse is turning. This is called the rotation of the perihelion of Mercury. This was known before. It was very accurately measured. Measurement is very important science. Measurement. And a certain number was calculated. Einstein's theory exactly predicted that number. He did not base his theory on approach of the perihelion of Mercury. So anyway, one evidence is found. Then what are the other pieces of evidence that you require? The gravitational bending of light. Last year was its century of its first observation. And the third one is the shift of spectral lines because of gravity. This was also found that yes, the stellar spectra do not fall exactly, all should be hydrogen. Most abundant element being hydrogen, all stars must be full of hydrogen. Now you look at the spectrum of hydrogen on Earth, and you look at the spectrum that is coming from the stars, there's a tiny shift, red shift, which is on the higher wavelength side. Now what could it be due to? This was not known, nor was it known before Einstein, but it was looked for only after Einstein gave these predictions. And all of them came out to be true, and not only tantalizingly accurate. Tantalizingly accurate. And what was the fourth one? That there should be a gravitational wave. That means if there is a gravitational field is changing, it should also travel as wave. And as it travels as wave, it will push one orbit in this direction, another orbit in this direction. You know, crests and troughs of waves, they move up and down. Now where to see it? It is impossible to see it unless you design your experiments. And the design of experiments, ideas came in around 1987. And for 20 years, they waited with tremendous investment in terms of money, in terms of people. No data were coming. And this is where it comes, is the confidence of the people who are working on it and confidence of the governments who believe that, yes, let us pursue. Let us pursue. No result for 20 years. And I know many countries would say that, stop it. Okay, but science, but if the governments have a confidence, or I would say also a will, a political will that science has to be investigated, in a fruitless, resultless research for 20 years, they still kept on giving money in terms of intellectual human power, in terms of equipment, and finally we know that the results came. Results came, if I remember, 2015 was the first unmistakable results, and many techniques have to be developed in order to do that. It is the work of astronomers, astrophysicists, physicists wanted to know it, but they couldn't do it without the help of an engineer. Not engineer, teams of engineers, including civil engineers. Because you have to have your laboratory, somebody has to build it so that there are no other vibration. Achari? No Vastu can do that. I'm absolutely sure. Okay? No Vastu can do that. So therefore, you should put that question also in your next. So So the science is interdisciplinary, it is getting more and more integrated, and this process is continuing more and more since the advent of, I would say, the 20th century science. We are in the 21st century, but we'll still say we are following 20th century science, because the science that we are following, they are principles laid in the 20th century revolution in science. Before that, we know of three major revolutions in science, and first one was, we can say, the Copernican Revolution. Copernican Revolution related to planetary motions. It was not Copernican that he came out of thinking just because of his free thought. There were hard data that orbits were not matching, locations were not matching. So here comes the importance of free thought. Things were not matching, so what was Copernicus's free thought? Let me try to abandon the Ptolemaic system. It was a very bold thought. It was not only free, but it was a bold thought also. And why it is bold? Because he was a Christian preacher. He was a Christian preacher in Poland, and he knew that he would be punished. Let us not debate what kind of punishment he would have, but he worked on that. He could have been proved wrong, because nature is not determined by my thought. Nature exists, and thought allows me to understand it, but not by thought alone, through experimentations. Now, this is a part of ingredient of experimentation as a very important ingredient in science. It did not exist before Galileo came. And this is the importance of Galileo. This is the importance of Galileo. Now, Copernicus did the experiment, gave the predictions, and predictions were beginning to be seen as tantalizingly close. And whichever direction you look for any planet, they look to be going on orbits, circular orbits around the sun. But there was one person who found that it is not exactly circular, and that was Jonas Kepler. And here I would say the story of Kepler. Kepler was an astrologer. He was an astrologer. And we don't know whether he really believed in astrology or sometimes he said, I cannot leave astrology because that's the only thing I know by which I can earn money. He was a practicing astrologer, but he was an astronomer par excellence. Very few have surpassed it, and mind you, in the pre-telescope days. He was working with another observational astronomer par excellence, and that is Tycho Brahe of Poland, or of Denmark, I think. And Tycho Brahe had his observatory where very accurate naked eye observations were made. And this man, that is Johannes Kepler, went to work as his assistant. But Tycho Brahe was a very rough, rude, and cruel man. He was a landowner who would be whipping his. So this man had to tolerate all these because he wanted, and when Tycho Brahe died and the family was trying to divide his property, what Kepler asked for are Tycho Brahe's observations. He didn't ask for Tycho Brahe's property or any share of it. He just wanted his observations. And he tried to fit the observations of Tycho Brahe with circular orbits. And he found, again, Mars. All others were more or less fitting to a circular, but Mars was not fitting. It was very close to fitting. 4 points of observations were there which were fitting, but 2 of them were not. 6 pieces of observation. Any normal mortal would say that these were errors and discard and say, yes, it is circular, but not Kepler. And why? Because he had seen Tycho Brahe taking the observations, and he knew that this amount of error is impossible. So what could it be? They were found to be elliptic. Then he tried to fit with all other orbits. They found, yes, they are also elliptic, but ellipticity is very low. Okay. Now, if that was not so, what would happen? I would say, not only science, even Panchangam makers will not be able to make their Panchangams because of ellipticity. Our calendars, as you know, don't match. Our calendars do not match because the tiny differences. Why the Islamic calendar is different from the Christian calendar? That is because Islamic calendar is based on the lunar orbit, which is somewhere between 28 and 29 days for an orbit to be completed. And solar orbit is 365.25 you can day. And you can see that 365.25 divided by 28 is not an integer. They are not integers, and that's why the 2 calendars don't match. Lunar calendar always moves backward. Okay. So it was a bit in the history. It was much later these calendars were reformed. And it was reformed at least for our Bengali calendar. It was reformed by Emperor Akbar. And he did not impose an Islamic lunar calendar because he knew the people there had their different festivals. And those festivals do not match with the lunar calendar. So what we follow in Bengal, which incidentally is very close to what many parts of India are now following, including the Malayalam calendar, by which our New Year's Day is around 13th or 14th of April. But Yugadi does not match that. Yugadi can be anywhere between 18th of March to 14th of April. 14th of April, it had matched in the year 2002. That is because lunisolar, nothing can match like that. Now, there is no freedom of thought that nature allows. This is what? Nature is not determined by your thought. Nature exists, and your thought and the process allows you to understand that. So this was the first landmark in a revolution because it completely changed our thought. A little bit of history in understanding science is required. Many people believe, or even I was taught in the physics course, as if Kepler found it just on one day, all the 3 laws. Not at all. First law, if I remember, was in 1605. Second law is roughly around 1609. And the third law in around 1614 or so. They didn't come at one by one. They did not come all together. Now let us see what it leads us to. Now, madam, you told us about the diameter of Mars, a diameter of the Earth. Its ratio is roughly 1:2. Roughly 1:2. Now that would have been known because these are only relative. But the exact, that Earth's diameter is 12,000 kilometers, the Mars is 6,700, these numbers were not known even to Kepler. It was impossible because Earth to Sun distance was not known. And that was first an evidence of it, or very semblance of its magnitude was known with a 1639. There was a transit of Venus. Transit means it is like, here is the Earth, here is the sun, and we know that we get eclipse because of the moon. Here the eclipse is not created by the moon, but the Venus goes across. It's like a tiny dot it is seen. And the people who seized the opportunity, the date could not be predicted unless we had used Kepler's elliptical orbit. It was not possible with Galileo's circular orbit to predict the date. It happened at the right time. So this is here, experiment was observed. And who were they? Again, they were two preachers, Christian preachers. Now these two Christians, Horrocks and Crabtree, the Christian preachers, they always taught creation, but they were not known for that. But they were the first people to understand Kepler, use Kepler's law to verify whether it's correct, check the transit of Venus, and through that you find the distance. And they were astounding distance that they found. And the distance they found was 99 million kilometers. Okay, so what was their yardstick? They had compared everything in terms of the Earth's diameter. Now, how did they know Earth's diameter? This has been known for a long time. And this was first found by Egyptians. Eratosthenes is the first person who found it, not by going with a tape, but he found the declination of the Earth, of the sun, on the same day at 2 points. One was in Alexandria, and another place is, nowadays we call the place as Aswan in Egypt. So here is the distance, angle from here is this much, angle from here is this much, so what should be this? What should be this distance? They did not know this distance. And extremely accurately, they knew. Extremely accurately, it's as roughly 12,000. And later on, I think it was found by Omar Khayyam, the great poet. He was a great mathematician. I would say he was a greater mathematician because he produced the most accurate calendar in the pre-telescope era. His method was also essentially the same. Now, he said, let us be on a desert. And in the desert, I put up a pole. And here is my observation. I go farther and farther. And let us see whether finally it vanishes. We know in the sea, many of you are from Kerala, I think most of you. If you go to the Cochin harbor, you might have seen the sea leaves, the ship leaves the sea, first the lower part vanishes, then the middle part, and finally the mast also vanishes, isn't it? And that is because it is circular. Here is the mast, it is going like this, and we don't. He essentially did the same thing, but not at the sea, but on a desert. Again, 12,000. So it is the repeated verifications which are the steps in science. Now, people talk of Newton. People talk of Newton's laws. Now, Newton did not find it with the apple. Apples fall all the time. In Kerala, you must be seeing coconuts falling, isn't it? But let anybody give me the law of inverse square through that. Let anybody try it. It's a myth. He found it only from astronomical observations. And these astronomical observations were Tycho Brahe's data, finally refined again by Edmond Halley. And most important part that Newton gave, it is a landmark in science, that law is not only gravitation, it is universal gravitation. Laws of science are universal, irrespective of whether you look at it, or I look at it, unless both of us decide to make inaccurate experiments. Okay, your result, my result can differ, provided one of us is cheating, that let me make it inaccurate. So this was a landmark, and I would say the Copernican Revolution's first landmark is Halley's verification on the basis of Newton's laws, the return of the Halley's comet, which he predicted the date. That Halley's comet, it is the one and the same comet which is coming for every close to 75 years, and that was the landmark. And from then on, now before the second issue comes, it is the Industrial Revolution. That is another revolution that we have to contend with. And it is here that finally the human thought, again, thought is very important. We never discard thought process. Human thought was going away from motions external to the body to motions internal. That is, why does something burn? It was a steam engine, was a motor force. What was giving it the motor force? It was the burning of coal. Then what is inside coal that gives the energy? It is a chemical energy. And that is how you go deeper into understanding what is inside matter. How the matter is in motion inside matter itself. And that begins the birth of atomic physics. Atomic sciences. It proceeds. It gets into a crisis. And in all revolutions in science are for the resolution of certain crises. Revolution at the time of Galileo or Copernicus was because of resolution in terms of invalidity of the Ptolemaic system. Revolution at the time of Industrial Revolution was because of a certain crisis by which motion has to be created, but not by animal power, by power which exists within matter itself. So that productivity of labor increases. This is a social drive. And third one, as you go with atomic physics, you come against certain crises, and they had to be resolved in the 20th century with the advent of quantum mechanics and the theory of relativity. And finally, the two were coupled by Dirac. So what we deal today is we can deal with quantum mechanics separately, we can deal with relativity separately, but we can also couple them together, what we call the relativistic quantum mechanics, with which in 1930, the revolution in physics was complete. But it was not a revolution in physics alone. It was a revolution in science. From physics, it went to chemistry, quantum chemistry. Why are chemicals formed? And without that, we couldn't have semiconductor physics. Okay. And then comes the breakthrough in technology, and that is again because of the invention of the transistor. And you know, we are living in that age. Many say we are living in the silicon age. Yes. And these, I would say, and I would just end by saying that all these they have not left any branch untouched, including biology. I won't go into that. And I'm coming to really to the end. It is extremely necessary for us to know all these. And in the present era, what is the technological revolution that has been ushered in the 20th century is doing to our lives, to our labor force? One summary that I can give you in one word, it has made the whole world into a global assembly line. You work here and your product is shifted immediately somewhere else. The assembly line has become a global, and it is this technological revolution which has made a global conveyor belt. That your product is immediately, and I would end here, and there are many, many such episodes. I would say that many of you would be able to collect them more and more in view of these kind of transitions that have taken place. I recommend please go through there's one essay which is called Freedom and Science by Damodar Kosambi. There are many things we could have discussed. Maybe I'll reserve that for some other meeting. Thank you very much.
Questions?
Yeah. Please. So there is a question here, and I understand the problem. Please explain what is space-time. Despite making lot of effort in watching ideas and reading, I couldn't comprehend their idea. Now, one should not be disappointed if one does not comprehend, because it is not an idea that we perceive in nature. We do not see space-time being coupled, because the kind of phenomena which will drive us towards that, we do not see it for ourselves. Now, how did the idea come? It is again, the history is required to be understood. It came with certain crises in physics which happened, which were discovered in the 20th, early or late 19th century. And these were the Michelson-Morley experiments. And Michelson-Morley experiments is this. Here it is. That suppose I fire a gun, and you are the observer, you are trying to find the time when which the sound reaches you. You note that time. Then you repeat the experiment, that moving towards me, and I am firing the gun. You will find that this reaches you earlier if you are moving towards me. And if you are moving away from me, the report of the gun will reach later. Now, once Maxwell's electromagnetism had shown that light is also a wave, then people wanted to test this. That if it be a wave, it should reach like this, as I said. And this is called Galilean relativity. This is the theory of relativity according to Galileo. That is, space and time are decoupled. This is Galileo's greatest, apart from other things, greatest theoretical contribution is that space and time are decoupled. And second thing is that everything has to be based on experiments. These are the two fundamental. So this is Galilean relativity. They found when you do with light, the Galilean relativity is not followed. No matter with what speed you approach me or go away from me, the velocity of light remains the same. What could it be due to? The first idea came with Minkowski. And Minkowski showed that yes, space and time have to be coupled. Speed of light has to be, if speed of light has to be conserved, irrespective of the observer, then space-time not only have to be coupled, they have to transform like this. And these are called the Lorentz transformation. Minkowski's continuum, space-time continuum, followed by Lorentz transformation, it rested there for a year or two. And then came Einstein. And he gave two postulates of relativity. And one of them is, again, very important postulate. Laws of physics are the same, irrespective of the observer. Okay? So there's no free thought here. Irrespective of it is a boundary of free thought, irrespective of the observer. And second, speed of light in vacuum is a universal constant. Now, when you deal with these two, you immediately come to a Minkowski space. And you immediately come to the same Lorentz transformation, which Lorentz has done without invoking any of these. And finally, he showed that mass and energy are related. Famous E is equal to mc squared. It is said to be the most popularly known equation throughout mankind. Everyone knows E is equal to mc squared. So therefore, this is to understand that one has to go through this historical process of thought, which is coupled with experimental observations. So thank you. Any other question, please? Yeah.
Sir, can you please write it, and because of the time shortage we have. Sorry. Maybe can you make it?
Thank you, Chatterjee, for telling that thought is not free, it is conditioned as it is. And you said experiment, observation, and inference. What about imagination? I say this because Einstein has said all are important, imagination is more important. And one more, that Kepler, astrologer and astronomy, thanks for that information. But then was Kepler doing the same way as Uppaldat, who was acting in commercial film to collect money to spend in his drama? Thank you.
Yeah. Two parts of it. As I said, neither experiment, nor observation, nor inference can go without imagination and thought. Thought is a part of all these. It is not empiricism. Science is not empiricism. So without thought, it is just empiricism. So that's first part. Second part is Kepler's own life. It is not known how much he believed in astrology. It is not known. Sometimes he said that if I had enough money through astronomy, I would have done only astronomy. He had said this. But he had certain unfortunate things in his life. And one of the unfortunate, and for which he needed money very badly. And one of the unfortunate things was his mother was imprisoned because she was thought to be a witch. And Kepler had to bribe the prison authorities so that she is not burnt alive. So he was always in need of money. And he found any means by which money could be had. And some of his predictions, based purely, I think, on common sense, turned out to be true. And once he was rewarded by the king. It just by common sense, but he was always, and he would never leave that profession. There was no other profession available to him. This is about, these are the two things, this is the two things about Kepler and role of imagination, but it is not free imagination. Einstein's unified field theory does not work, though he is Einstein. But we give credit for where it works, okay? And we waited 100 years because we had a concept ever since the time of Newton that laws of science are universal. If 3 of them have worked, we anticipate the 4th one will work. But if it did not work, we have to revisit everything. For example, we know electron is the lightest particle with the smallest amount of charge. If anybody finds a particle lighter than this, or a charge, entire edifice of science of electromagnetism will collapse. And if it comes, scientists will have to grope with that. This is what science is. The other thing is, would it be safe to say Indians currently lack scientific temper? If so, where did we lose our way? I cannot deal everything. Certain Indians definitely lack scientific temper. Okay. And it is for the citizens to see that scientific temper once again prevails. And since the word scientific temper has come in, I would just use 2 quotes which I found are very profound. One is the word scientific temper comes from Nehru in Discovery of India. And one sentence that he uses is and after little elaborate study of history and history of science, he comes that scientific temper is the temper of a free man. But today, I would rephrase it, scientific temper is the temper of a free individual. And here comes science and freedom. So therefore, I recommend this essay by Kosambi. And Kosambi says, science is the cognition of necessity, while recognition is science is the cognition of necessity, while freedom is a recognition of necessity. He says the first part is his, and the second part is taken from Friedrich Engels. And Engels, in turn, attributes that he was inspired by Hegel. Hegel's thought. Freedom is the recognition of necessity. One simple example, if I am hungry, the necessities of food, I'll be free from hunger only when that food is supplied to it. So freedom has to be the recognition of that necessity. Now, amount of yoga is going to help me in that. Am I right? As a physiologist or whatever you are, no amount of yoga is going to help me. It is the recognition against and cognition. What will bring it? Agriculture and distribution. So I think these are the two most profound things we must keep in mind. And one is a question of scientific temper that Nehru attributed through a study of history. It was not just out of fancy. Study of history, and that study of history is still relevant, and we have to bring it back. And the second part is science is the cognition of necessity, freedom is the recognition of necessity. Very profound. I think we will continue to debate throughout on these concepts. Thank you very much.
Neurons English is your one-stop free thinking channel. Subscribe now and get instant alerts on videos from Essence Global.